Hello everyone, my name is Sandeep. Welcome back to another session of BGP wherein we are going to discuss BGP load balancing with a loopback IP address and we will understand what is load balancing. Okay, today we have got this topology wherein we are going to discuss how we are going to load balance the traffic from autonomous system 100 to autonomous system 200 and we are going to configure that using loopback IP address. So in our topology, we will do a BGP peering from R1 loopback IP address 1111 to R2 loopback IP address, and we are going to advertise some routes from router 2 to router 1, and we will see how the route looks into the BGP table. And when we do a ping or trace route, so we should see that the one packet is going over the first link and the another packet is going over the second link. Okay. So let's see, we have got these interfaces Ethernet 0/0 and 0/1 here. Okay, so before we start with this, let's understand uh, how many types of load balancing we have and what is the meaning of load balancing. Okay, so let's say that we have these two routers. Let me take a screenshot of this and I'll try to explain there what is load balancing or load sharing. Okay, so here we are going to discuss, let's say I have a route here with 200.0.0.0 and I learned this route on the router 1. Okay, so I have this route onto the router 1. Now let's say I have some computers in my LAN who wants to access this 200.0.0.1 network or 200.0.0.0 network, which is into the service provider end. Let's say I have a server here 200.0.0.1. So when I want to access this 200.0.0.1 server from this client machine, so the traffic goes here onto the router 1, and router 1 has two paths to the 200.0.0.1, one via Ethernet 0/0 and one via Ethernet 0/1. Okay, so when you configure the load balancing in your routing table, you will see the two exit paths for this destination. So one packet will go via this interface, the other packet will go via this interface. Okay, so this is called the load balancing, which means that the traffic is distributed between the two links. Okay, so basically there are two types of load balancing. One is called as per destination load balancing and the another is called as per packet load balancing. Okay, so we will discuss about the per destination load balancing first. Now the same topology, let's say I have one more network here with 200 and or 130.0.0.0. Okay, so this network is learned on router 1 as well, and 200.0.0.0 network is also learned on router 1. So when this computer wants to access 130 network, it will take the first path Ethernet 0/1. When he's accessing 200.0.0.0 network, it will take the second path, the second link. This is called per destination load balancing, which means that the router 1 has destination 130 as well as 200, and it has two links. So whenever any users trying to access the first destination, it will use the first link, and when the users from our LAN side trying to access the second destination, it will use the second link. This is called as per destination load balancing. The second type of load balancing we have got is per packet load balancing. Okay, so per packet load balancing is that, let's say you have only a single network. Let's say we don't have 130 network, we have only 200.0.0.0 network, and you are accessing this server from this client. Let's say my destination server is 200.0.0.1. So whenever I'm accessing this 200.0.0.1 from my client side, one packet will be sent on Ethernet 0/1, one packet will be sent on Ethernet 0/0. This is called as per packet load balancing. So when you configure the per packet load balancing, it is going to take more processor hits, and the CPU and RAM will be utilized more on the routers. So most of the routers by default are configured as per destination load balancing. Okay, please understand that by default all the routers comes with a per load the load balancing scheme, which is per destination load balancing, which is written here. You can disable the per you can disable this per destination load balancing and enable per packet load balancing using a single command on the Ethernet interface, that is no IP route cache. So if you want to enable um, the per packet load balancing on this router, on this interface, you are going to configure this command, no IP route cache. Also on the second interface you can configure this command, so the per packet load balancing will be enabled here. All the new routers are coming with a new switching scheme that is called as Ceph or Cisco Express Forwarding, and mostly the new iOS after 11.x are using Ceph by default. So Ceph has the capability to do both of this per packet and per destination load balancing. Okay, so let's read some notes from the Cisco website directly. So here you see that per destination load balancing means the router distributes the packet based on the destination address. We have discussed this. If you have two paths to the same network, are all packets to destination 1 will go over one path, and all to the destination 2 will go over another path. That's what we discussed here. Per packet load balancing also we have discussed. One packet will be sent on first link and second packet will be sent on second link. So per destination or per packet load balancing depends on the type of switching scheme used for IP packets. So routers are performing our routing. So IP packets are observed at the router. By default on most Cisco routers, fast switching is enabled under the interface. Fast switching is nothing but your per packet load balancing. If you want to disable the fast switching and enable process switching, then you can use this command, no IP route cache. Okay, I hope that overview was clear to you. So let's go ahead and do our configuration in the related to the BGP, and we will enable the load balancing in a single home BGP environment. Single home means that you have a single router from your customer edge to the provider edge. If you have multiple router, let's say I have one more router, then it is called as dual home. In this case, if I have one more router here and I have one link going to this router, then that is called as dual home. Okay, so in today's topology we are going to use a simple topology and we'll discuss this. So let's jump on to the router 1. So let me start working on the router 1. Let me execute a command, show IP interface brief quickly, to see if we have any IP addresses. We don't have any IP address. So what I'll do is I'll quickly configure the IP addresses. IP address 10.1.12.1 interface Ethernet 0/1 10.1.23.1. Okay, so I have these two interfaces configured. Interface loopback one I'll configure, and I'll configure IP address 1.1.1.1. Okay, so what I have here is I have configured these interfaces. Okay, so 10.1.12.1, 23.1 and 1.1.1. This is loopback IP address, and these two are the Ethernet interfaces. So let's do the similar configuration on router 2. 12.2, 10.1.23.2, interface loopback 2, IP address 2.2.2.2. Okay, so let's quickly verify our interfaces. Okay, so we have these interfaces configured and we have this up. So let's start doing the BGP configurations. Router BGP, let's start with this side on the router one. Router BGP, let's say 100, and I am forming a neighborship. Okay, so when I am having the loopback interfaces, we are going to configure the BGP neighborship with this loopback IP addresses and not with any of the IP addresses here, because if this link goes down, let's say I have configured BGP peering with 10.1.12.2, and if this link goes down, then you don't have the connectivity with BGP, or the BGP will go down. So the best option for us to configure the loopback IP addresses on the router, and we form a BGP neighborship with the loopback IP addresses. This is the reason we have configured loopback IP addresses, so that we can form a BGP neighborship there. Okay. So just one more thing, if you notice that before we start doing a BGP configuration, we should have a reachability to 1.1.1.net 2.2.2. network from router 1. So or ping 1.1.1 2.2.2.2. I should have a reachability, but I will not be having any reachability because we don't have this route. If you do show IP route, you don't see this route here because we are not running any routing protocol. So to get this route advertised into the router 1, we will configure any of the IGP. We can configure either the static route or EIGRP or OSPF or any routing protocol. In most of the scenarios, it will be static route in production network, but I'll just go ahead and configure the dynamic routing. So let me advertise this network 10.1.23.0. Similarly, I will go to router 2, router EIGRP1, network 10.1.12. network 10.1.23.0, network 2.2.2.2. And now we should see that I have the 2.2.2 network here in my topology. So I have the reachability from my source IP address of 1.1.1.1. Okay, so now I have the reachability to the 2.2.2. network. I'm good to configure the BGP now. Router BGP 100, neighbor 1.1.1. Sorry, neighbor 2.2.2.2, and remote autonomous system is what? 200. Okay, let me do a similar configurations here. Conf t router BGP 200, neighbor 1.1.1.1, remote autonomous system is 100. Show IP BGP summary. Okay, so you will still not be able to form a BGP neighborship here. Let's give a couple of minutes so that the BGP should come up. However, it will never form a BGP neighborship. The reason being that you still have many configurations to configure in the BGP. There are many configurations are missing here into the BGP. So the first configuration is that router BGP 200. You need to configure the update source with its own loopback IP address, because what happens is that when you send a packet from this router here, Okay, so I'm going to send the packet from this interface. So my source, the BGP source packet will be from 2.2.2.2. Similarly, I will be sourcing my BGP updates from 1.1.1.1 so that the three-way handshake of TCP will happen. As what would happen is that if I don't configure this loopback to 2.2.2.2 as my um, update source, it will be sourced from one of the interface. Let's say I'm sending a packet, source packet with 10.1.12.2, the SYN packet, and when I'm getting a CNAC packet, I will be getting it from some other interfaces. I may get the update from 10.1.23.2. So TCP out of um, TCP out of packet things happens here, and the BGP will not be formed. So let's do quickly 1.1.1 update source loopback to, similarly neighbor to update source loopback 1. There is one more piece in the BGP which is missing. You could see that it is still idle state. The one more piece of it is that we need to configure eBGP multi-hop, because this network here, let's say 2.2.2.2 network, is two hops away from 1.1.1 network. So the first hop is this one, and then it has to go here. So it is two hops away from the um, 2.2.2 network, because my first loopback interface is here. Let's say my first hop is here, so I should configure eBGP multi-hop here, else it is not going to work. Neighbor 1.1.1.1 eBGP multi-hop is 2. I should form a BGP neighbor now. If you notice that it has moved from idle to active state. Okay, you could see that the BGP neighborship is up now. It has not received any prefix because we are not advertising anything from router 1. So let's go ahead and advertise some route either from router 2 or router 1. Let's advertise from router 2. Let me configure interface loopback 200, and I'll give IP address as 200.0.0.1, and I will advertise this route into BGP. So to advertise this route, I need to use 200 network command, mask 255.255.0. I will go to router 1 and see and verify that whether I have received the new route. Show IP route 200.0.0.0. Okay, you could see that I have received this route from BGP 100. If you also execute show IP route, you could see that this route is received here. Okay, so when you do a show IP route 200.0.0.0, show IP route 200.0.0.0. Okay, so to reach this route 200 network, I need it is showing that the routing is learned from 2.2.2.2. So 2.2.2.2 is nothing but the loopback IP address of router 2. So if I do show IP route 2.2.2.2, you could see that this 2.2.2 network is learned from two interfaces. One is Ethernet 0/, 1 and one is saying that it is learned from Ethernet 0/0. Okay, you could also see that the traffic share count is 1 here and traffic share count is 1 here, which means that the traffic is equally distributed between the two links, Ethernet 0/0 and 0/1. Okay, so what we will do is we'll just do a trace route 200.0.0.1. You could see that the load balancing is happening here. The first packet is going via 23.2. Let me just bring up this topology here to make you understand. Okay, so you could see that the first packet is going via it's hard to get this moving here. Okay, 23.2. 23.2 is nothing but this interface Ethernet 0/0, and then it is moving via 12.2. So the very next packet is going via Ethernet 0/1. Okay, so again the next packet is going via this. So it is doing a load balancing across the two links. Basically we are using the BGP here. However, it is doing the load balancing using the IGP. IGP we have used is EIGRP routing protocol, and it is doing the load balancing using EIGRP. So if you do a show IP route, however, show IP route 200.0.0.0, you could see that if you look at the routing table, you are seeing that to reach this 200 network, I need to send a packet to 2.2.2.2, or the 200 network is learned from 2.2.2.2. So this router will do one more routing lookup, and then it will define how to route the traffic. So if you look at this, you would think that the traffic is not getting shared. Okay, so basically the load balancing is not happening using the BGP routing protocol. It is happening using the EIGRP routing protocol. If you see that traffic share count is 1 here. Okay, however, when you do a trace route, it is using, so how it would be done is that if you see show IP route to the 2.2.2 network, you could see that it has two paths, routing entry known via two paths. One is Ethernet 0/0 Ethernet 0/0, and one is via Ethernet 0/1. So let's do and fix some configurations. No auto summary. Okay, and also we will do one more command, router BGP 100 maximum path 4. There is a command called maximum path. If you really want to do a load balancing using any other routing protocol, for example, if you want to do it via BGP, then you need to configure it using maximum path, so that it allows multiple paths or multiple routes. So IP BGP. Okay, however, it's showing that it has only a single path to reach via 2.2.2.2, and internally it is doing the load balancing using IGP, that is EIGRP we are using. So in my next video, I'm going to discuss the BGP multi-homing, wherein I will show how we can use this maximum path command in BGP to load balance the traffic, and we will discuss that in more details. If you like this video, please hit the like button and subscribe to my channel to get more videos. Thanks a lot for watching and have a good day.